Hey people, what's going on? Welcome back to the channel. I hope you're well and in good health. Okay, just a quick one really. So if you are new to the channel, just a quick reminder, please do like, share, subscribe, all the good stuff. You can now also join our YouTube channel as a member and get access to loads of perks on there. Check it out by clicking join and do consider supporting us on Patreon. You can actually get videos if you can see them before others, and there's all sorts of stuff out there in regards to cryptocurrency and business development and so on. Okay, so let's check this article out today. We'll just have a quick look at blockchain technology and just kind of like explore a little bit about what it is and how it works type of thing. Okay, so in this Cloudworth article, we're looking at blockchain tech, which is supposed to be the future of payments, data storage, and more. But in essence, a lot of people don't know what blockchain is right now. So let's have a little delve into it. How can it be used and what are some of the issues around it? So in recent times, you can't have read more than a few articles on tech without coming across the term blockchain because it has risen to popularity. So it's a technology that powers Bitcoin and other cryptocurrencies, for one. But let's find out how it works. So according to this article, some of the key takeaways to understand blockchain are: blockchain is what it says on the tin, a chain of blocks with each block containing a small amount of data. The data in a block is immutable, it can't be tampered with in any way. This is great for informational security. Now, we are living in the age of technology and obviously internet data and so on. So cybersecurity threats are real. So blockchain is quite useful in that sense because the nodes and the blocks on there that contain the data digitally, they can't be messed about with, tampered with, like you said here. So that is good for cybersecurity to protect that information. Okay, so blockchain is relatively new tech that has a lot of potential uses, but for now it's almost exclusively used for cryptocurrencies. While blockchain could be groundbreaking, there are some serious issues with it that stand in the way of widespread adoption. Okay, so as with all heavy high technologies, a lot more to blockchain that you think at first. It's just the engine that made crypto possible. It's not just that engine, but it can also be used in all kind of projects, works that are being undertaken in order to secure and safeguard all the data. However, due to the way technology works these days, there are some, potential negative sides to the performance along this. So let's take a look at a bit more about blockchain. So blockchain is essentially a block, is a piece of data like a transaction or a smart contract. The data in a block cannot be changed once it's created. And I guess that is the USP, the unique selling point in regards to blockchain. What is the difference between blockchain and cryptocurrencies? Obviously, this channel, we have a lot of cryptocurrency content that we produced, dozens of videos out there. So cryptocurrency is a medium of, storing value in terms of digitally buying and selling on blockchains in comparison to your traditional banking and physical cash kind of deposits and transactions. So cryptocurrency, the digital currency, is secured by cryptography. Blockchain is a technology that makes sure these tokens are secure. So you have tokens like Shiba Inu coin, Bitcoin, Ethereum. Ethereum is also a blockchain as well. Okay, so what is the longest running blockchain? The digital ledger that keeps track of Bitcoin is the longest running big blockchain. Okay, so some basics around blockchain tech. Blockchain technology, also known as distributed ledger technology, is pretty complicated concept, but in essence is a new kind of database. So we probably all used to having our data on, some people use spreadsheets or whatever to store data, in the past, and other kinds of specific software tools that allow you to import data. But with the advent of cryptocurrencies and blockchain, you can store data on these blocks. So in most cases, data is stored in tables, master spreadsheets where the computer can find what it needs. If you need to find a transaction from a certain date, you feed your parameters to the computer and it goes and finds that data. Now, distributed ledger technology in comparison doesn't store data this way. As you can guess from the term, the way it works is much more akin to a ledger. So those tall books used by bookkeepers in a ledger, transactions are written down in chronological order, which is useful, and can usually only be retrieved the same way by going back through time and finding the transaction you need. So that's the secure element around it. Blockchain takes this concept and runs with it. Each entry in its ledger is a so-called block, a unit of data. A block can be just about anything that's happened on a blockchain, a cryptocurrency transaction, smart contracts. So a lot of people nowadays are building out smart contracts on blockchains, and you can name them as you want. So these are usually quite small as well. So Bitcoin limits its blocks to 1 megabyte, for example. Okay, so block to block. Each time a block is written, it's sealed off and encrypted, right? That's the encryption element. So it can't be altered in any way. As a result, all data written to a blockchain is immutable and can't be changed or tampered with. Once again, USP here is the element of not being able to mess about with the blockchains once they've had data inserted into them. People can't change things, tamper things, alter things, add, delete. So it's basically once it's there, it's there. This is what makes blockchain so attractive theoretically. Data can't be messed with. After the fact, it adds a lot of security to whatever data is stored there, and that's good for cybersecurity elements. Right, that's a block part of the blockchain. The chain in this way in which data is stored, rather than place each block in a table like regular data, each block instead is attached to the next one, creating a chain of blocks. Each block is a link in the chain, and there is no theoretical limit to how long one can be. Okay, interesting. Now, this goes on to say the reason why blocks are chained like this gets incredibly technical, but the short version is that it adds a layer of security. The link between blocks acts like a kind of seal that shows when a block was closed off, as well as adding an extra layer of encryption, right? So obviously encryption end to end is great. You'll see that on some of the messaging apps as well. Slightly different format, but encryption is good for privacy and so on, and also security. This is added guarantee that the block has not been tampered with in any way. Now, distributing data across these networks. Right, this method of skewing data isn't the only element blockchain has up its sleeve, and the kind of positive side to it. Another key ingredient or advantage is where blockchain data is stored, or rather where it isn't. Unlike traditional data, a blockchain isn't stored in a single place, but rather across a decentralized network. Keywords here: decentralized network. So in a way, each blockchain exists in several places at once. If you're familiar with the concept of syncing cloud storage, where one change in a file will instantly be reflected across all of the instances of that file, this is where the block comes back in, right? So since a block can't be altered after it's written, an attempt to do so would essentially alert other instances of the blockchain and prevent the change from going through, which is the encryption and security element to these blockchains. Now, blocks and the distributed database is basically what keeps a blockchain safe. For example, when you record a transaction, the data is locked away safely, while the blockchain network makes sure there isn't anything suspicious going on there. Right, transparency and accountability, which are key elements, particularly in the financial space. So, as a result, blockchain tech is highly transparent. Any transaction that has been made reflects across the entire blockchain network. So, anybody who has access can see what's going on. Obviously, this is the transparency element to the use of blockchain. For example, Blockchain Explorer is one of many sites where you can see what's happening on the Bitcoin blockchain at any time if you want to. Now, of course, not all blockchains let just anybody check. The Bitcoin network is an example of a public blockchain, but there are plenty of private blockchains also. Okay, however, the main difference is based on who has access, not the data available. Any participant can validate transaction, check on what's going on, and see everything that's happened with specific blockchains. So, what can you use a blockchain ledger for? So, with this type of technology, it's quite good for variable industries that already use ledgers. And one kind of element to this might be financial institutions who are looking at this tech to keep track of data in a manner which is transparent for their customers, which will obviously create loyalty and trust, respect, and better relationships. So there are plenty of other fields that could, use this kind of tech as well. For example, one entity wants to store digital identities on a blockchain, making it so anybody can see exactly who they are and what they've been up to. Blockchain has been proposed as a way to protect copyright. So, for example, if you've got like a logo or something and you want to copyright it, or if there's a specific kind of uh, product that you have. Some promoters even claim it could improve government services, like allowing voting via blockchain. So that could be useful in terms of voter fraud or ID fraud, that kind of stuff, or following the authorities' procurement process step by step. Again, smart contracts, procurement to contracts, tenders, the government portals could use blockchain in terms of transparency as well. And in each of these elements, putting data in the ledger could provide great security for users whilst also adding transparency, as we mentioned. Now, blockchain and cryptocurrency. If you want to see blockchain tech in practice, the only real place to go is the wonderful world of crypto and its related Web3 applications, right? So Web3 is a new kind of thing happening right now in terms of the development and evolution of the internet space, and obviously blockchain is a part of that. In fact, the two are conflated so often that they have nearly become synonyms. Okay, this isn't really surprising, as crypto is how people have become acquainted with the blockchain, and so far it's the only place where we can see its full potential. Now, in fact, without blockchains, there's been no crypto. That's the power of blockchain. The idea of digital currency is far from new, but usually ran into the same simple problem. There was no way to prevent anybody from simply creating more of it, essentially, imitating, copying, and then increasing the volume. So plenty of projects came and went, but all eventually failed, simply because there was no good way to secure payments. Securing Bitcoin and other cryptocurrencies. So that's the famous Satoshi Nakamoto back in 2007, his white paper, Bitcoin, a peer-to-peer electronic cash system. Now, in that document, his kind of whole idea laid out on how to the blockchain tech could be used to secure currency, and obviously that was through the medium of Bitcoin crypto. And it should be noted that Nakamoto isn't the inventor of blockchain, though just one of the first people to find a good use for it, a good way to implement it. And obviously as a result, you've seen what happened to Bitcoin. Started off with very small kind of value, all the way up to thousands of dollars, and currently it's just somewhere around the 23k mark in terms of value. As a result, Bitcoin is often seen as a kind of blueprint for blockchain, even though some of the things it does are unique to Bitcoin and not necessarily to all blockchains. And obviously, Bitcoin mining is one of those. What we'll see in 2024 is halving of Bitcoin mining as the number of Bitcoins available decrease, because there's only a set amount. So that's that. And then it goes on to talk about another example is the Ethereum blockchain, which is home for its own currency. Yes, I have invested in Ethereum, and I know many people, other people have as well. So Ether also lets you host applications and execute smart contracts and much more. So where Bitcoin can, prove that blockchain can work, and Ethereum really shows the breadth of its potential. There are some downsides. So some of the news surrounding this tech, like blockchain systems, securing data, is positive. However, not all that glitters is gold, and there are some serious issues with blockchain that cast doubt on its viability. The least technical issue, but one that may be the most important one for many people, is where the line between transparency and invasion of privacy will be drawn. Blockchain makes data transparent, which in this case a cryptocurrency is very much a good thing. For example, it prevents people with ill intention from duplicating coins at random or claiming payment never arrived. However, if you start using blockchain to store personal details, like in some projects, they might, whether we really want everybody to be able to access all data becomes questioned there in terms of ethics. How much data do you want available? We've seen data breaches across many of the social media platforms over the last few years. So while it may seem cool to have your driver's license stored online, not everybody wants that information, has good intentions. So transparent information source like the blockchain, could cause issues around security and access. So that's one of the worst case scenarios, and there might be others too. So when you make lots of data accessible in this manner, you do open it up to various elements such as cybersecurity issues, identity theft, all this kind of stuff could occur. Okay, so yeah, just to finish off, we've got here blockchain security issues. So there are concrete problems with the technology. A big issue is while the actual chain is secure, the points of access, passwords, and apps that interact with the blockchain, increasingly they may come under attack. Encryption and other tricks may protect against brute force attacks, but are not a match for social engineering and other things like phishing attacks and so on. Okay, so I hope you've enjoyed this kind of video today, delving into blockchain, Web3, and elements and issues around that positive side and also negative sides. Please do like, share, subscribe, support the channel by joining, and also support us on Patreon, link in description. Okay, gladiators, let's make some guala.